Welcome back, Leo Lions. This is Mrs. Morgan. Today's lesson, we're going to continue on with square roots. This time we're going to estimate them. So we're going to look at square roots that don't come out to perfect square roots and see if we can get at least close to estimating them. So perfect squares, remember we talked about those in the last lesson, and I already wrote down all the perfect square roots here on the side. Just so that we can use them to refer back to when we start estimating them. So perfect square are numbers whose square roots come out to be perfect whole numbers. Okay, I think we talked about in the last lesson, square roots, most of them don't come out to a perfect whole number. Only kind of these on the side, and then the pattern keeps going, so it has to be a whole number multiplied by itself. So you notice all the numbers, or all the square roots that would go in between here. So the square root of 2 and the square root of 3, the square root of 5, square root of 6, square root of 7, square root of 8, square root of 10, square root of 11, so on. All of those are not going to come out to perfect whole numbers. They're all going to be really long decimals. So examples of perfect squares, something like 1 times 1, 2 times 2, 3 times 3, the answers to all of those. So something like 1 times 1. 2 times 2 is 4, so 4 is a perfect square. 3 times 3, we only have room for 3 examples, so I'm only going to write 3 down. So 3 times 3 is 9. Let's do a bigger one, maybe 8 times 8 is 64. So there are 3 examples of perfect squares, but like I said, I have a big long list over here on the side that I did for you. So non-perfect squares, if perfect squares come out to whole numbers, non-perfect squares are square roots that are not whole numbers. They come out to a big, long decimal. Some examples of some non-perfect squares. Like I told you, all of the perfect squares in between these, or all the square roots in between these perfect square roots, those are examples. So something like 6, for instance, that's in between our square root of 4 and 9. It's not going to come out to a perfect square. Something like 13. Something like 107. Okay, some examples of not square roots, not perfect squares. So we can use this knowledge of perfect squares to help us estimate the value of non-perfect squares. So for instance, we're going to estimate the value of the square root of 50. So we want to come over to our perfect squares and figure out, okay, where would the square root of 50 lie? Well, if we're looking at this list, 49 and then 50 would fall in between these two. So one side of it, the smaller end, is the square root of 49, and then the square root of 64, and we know the square root of 50 falls in between there. So we want to look at the actual values of the square root. So the square root of 49, what times itself gives us 49? Well, that's 7. What times itself gives us 64? That's 8. So we know that the square root of 50 has to be somewhere between 7 and 8. So we know, and this is the approximate sign, it's approximately about 7 point something. Okay? Now, if we were actually to figure out where would this go, 50, the square root of 50 is going to be closer down here, because the 7 represents the square root of 49. So 50 is one number away from 49. However, it is 14 away from 64. Since 50 is closer to 49, the square root of 50, it has to be less than 7.5. So it's going to be closer to 7 than 8. Okay, it should be just a little, because it's so close to that 49, just a little over 7. So a good estimate, again, there's that approximately sign. So it's approximately, I'm going to say about 7.1. Okay, and we know that because it falls, it's pretty close there. So I'm going to show you that this is representing that square root of 50. Okay, let's do another example. So the square root of 22. If we come over here, I'm going to pick a different color. So you can follow along with what I'm doing. Square root of 22. So where would the square root of 22 fall in between? Well, it'd be right in here, somewhere between the square root of 16 and the square root of 25. So again, I'm going to put that on my number line. This is the square root of 16. This is the square root of 25. Again, what are those values? So 4 times 4 gives us 16, and 5 times 5 gives us 25. So we know the square root of 22 is somewhere between 4 and 5. I'm already going to write down here that it has to be 4 point something. But which one is it closer to? So the square root of 22, I'd say it's somewhere in here. Remember, halfway is 4.5, right in the middle. So the square root of 22 is definitely closer to 5, so it has to be greater than 4.5. Again, from here it's kind of an estimate. Halfway in between 16 and 25, that's 9. So right in the middle of those two numbers, or at least the average here, would be about 20. Would be, about 20 and 21. So let's go with about 4.7 as our estimation there. Okay. Again, let's look at another example. So the estimate the value of square root of 103. So that's going to fall somewhere after the square root of 100. So in between the square root of 100 and the square root of 121. So the square root of 100, 10 times 10. Square root of 121, 11 times 11. So we know it has to be somewhere between 10 and 11. So we know it has to be 10 point something for our approximate. The square root of 103, well, it's closer down here. Okay, remember, halfway is about 10.5. So we know it's closer to 10. It has to be less than 10.5. Again, it's pretty close to 100. It's only 3 away. And it's much further. It's 18 away from 121. So I would guess maybe 10.1, maybe 10.2, close, but I would go more towards 10.1. Okay, again, it's an estimation. So usually I give you credit if you're either above the 0.5 or below the 0.5, depending on which side it's closer to. Okay, let's go to the second page then, a couple more examples. So which of the following square roots is best represented by point A? So if we were thinking about those perfect square roots, 3 times 3 is 9. So the square root of 9 is 3. 4 times 4, so the square root of 16. So the square root, this A value, it's got to be pretty close to this square root of 16. So I would guess, it's pretty close. So square root of 15 is the best representation. Okay. Next one, which of the following would be the best estimate for the square root of 198? So I'm going to draw our own number line here and think about what two perfect square roots does 198 fall between. If you forget, go to that page before. I have them all written down. So the square root of 198 is going to fall in between, down here, 196 and 225. So the square root of 196 gives us 14 times 14, so it gives us 14. And then the square root of 225, 15 times 15. So the square root of 198, remember this is the halfway point, that's about 14.5. So 198 is going to be pretty close to that square root of 196. So it's going to be 14 point something. We know it's going to be less than 14.5, so this is our best estimate for it. Okay, 14.1. Sorry, I'm going to make sure you can see the number 14. All right, square root of 90. So here's where we really like, and really helpful to use that list that we have on that other page. So let's see, 8 times 8 is the square root of 91. I put it to the right because 90 is less than 91. So the one before that would be 8 times 8, and that would be 64. So we know the square root of 90 falls in between those two. So it's somewhere between 8 and 9. Again, you want to take the actual square roots of these two that I wrote down. Okay? Square root of 175. I don't know those big numbers as well. So 175 is going to fall between this 169 and 196. So 169, the square root, that is 13. And then 196 square root is 14. So the square root of 175 falls somewhere in between those two. So we know it has to fall between 13 and 14. Okay? If it's a negative number, well, we're looking at the square root the same. We're just going to have negative values. So the square root of 12, what two perfect square roots does it fall between? We've got 3 times 3 is the square root of 9, and then 4 times 4, so square root of 16, and 12 falls in between those. So we know the square root of 9 is 3, but we have that negative in front of it. So we've got it somewhere between -3 and -4. All right. Next example, Rebecca bought a square table for her kitchen. The area of the table surface is 65 feet squared. So we've got a square. Remember we talked about area is everything inside of here. So if we know the area of that table is 65 square feet, we know it has to be something times itself because it's a square. They have the same side measurements. So what times what gives us 65? Well, we're looking for the approximate. So it's exactly what we've been doing. We want to find the square root, and that will tell us what times itself gives us 65. So the square root of 65, if we think of our number line, it falls between the square root of 64, that's one less than the square root of 65, and then square root of 81. So we know it has to be somewhere between 8 and 9. So I'm going to do my little approximate. It's going to be 8 point something. The square root of 65 is really, really close to that square root of 64, so I'm going to estimate it about 8.1 feet for each side of that table. Okay? And last part, let's create and label a point on the number line below to represent an estimate of the following square roots. So if we wanted to, we could go through and write down all the perfect square roots. 1 times 1 is 1. 2 times 2, so square root of 4. 3 times 3, square root of 9. 4 times 4, 16. And I'm going to keep going, square root of 25, square root of 36. And all I'm doing is taking that number, multiplying it by itself. 7 times 7, 8 times 8, 9 times 9, 10 times 10, and 11 times 11. So if we wanted to actually plot these points, I'm going to do each one in a different color here. So point A, I'm going to do as purple. Square root of 5, so we know it's got to be about in here. And let's label those points. So that is A. Sorry, that is not a good A. B. Let's see, let's do it in green. So we got the square root of 88. So let's see, we got to go down, we got to go past 81. There's a 19 in between 81 and 100. So a little less, it's less than 8.5 or 9.5. So I'm going to say about here. I'm going to get rid of that halfway mark. And that would be the square root of 88. So that is point B. Point C, the square root of 17. So that's going to be really close to the square root of 16 because the square root of 16 is our perfect square. So I'm going to say, actually I'm going to put it even closer. And that's going to be C. D, we got the square root of, I'll do orange, 118. So that's going to be past 100, and it's going to be awfully close to the square root of 121. It's only 3 away. So that is D. And then E, let's see, square root of 56. So square root of 56, it's going to be somewhere in between this 49 and 64. And I'd say it's going to be pretty close to the middle. There's 14, 15 away, and 56 is 7 away. So yes, it's going to be very close to the center of 7.5. And I'm going to label that one E. All right. So there we go. That is estimating square roots. And this is going to help when we, in the future, are going to put numbers from least to greatest or greatest to least. And so estimating square roots will help us with that. All right. Thank you so much.